Let's consider an example now. Suppose that we are given this again table which contains the market prices of 4 different bonds, and each bond has its own specifications like what's the face value, time to maturity, and coupon rate. So if you want to calculate zero rates, we can do that for each of these time to maturities as we did before. And additionally, this time we can do a few more things. We can also calculate the forward rates. We can calculate the par yields. And we can also do a pricing of another bond, which is a 2-year bond, providing a semi-annual coupon payment of 7%. So if we start by calculating the zero rates, it's just like as we did before. So I have the MATLAB code here, and you can notice that I'm using the continuous compounding here. So for the first one, you can notice our information. This is 0.5. There is no coupon payment, and the bond price is $98. So if we do this calculation in MATLAB, we have 2 times the natural log of 1 plus 2 over 98. So this gives us the zero rate for the half-year maturity. For the second one, you can do, again using the table, you can see that we have 0 coupon payment and we have $95. So we can do the natural log 1 plus 5 over 95. So this gives us a zero rate for the 1-year maturity. And for the 1.5-year maturity, again, you can notice that this time we have coupon payments of $3.1 every 6 months. So we are going to use, we will actually here we are directly solving the equation with respect to the unknown, which is now 1.5-year zero rate denoted by this R3. So that's given by calculating the present value using the right zero rates for the previous cash flow. These are the coupon payments, and we subtract that from the bond price, and you divide it by this. This is the last payment, $103.1. That's at the end of the 1.5 years. And if you divide this natural log by 1.5, then you will get the zero rate for the 1.5-year maturity. So you can do the similar operation. Once you get R3, now you can use R3 in the next zero rate, which is going to be for the 2-year. And if we do these calculations, basically the zero rates are obtained here. You can verify these calculations by yourself as well. And the next thing we can do is the forward rates, of course. And we will need to calculate the forward rates for the 6 months to 12 months, 12 months to 18, 18 to 24 months. So we are just going again in the increments of half year. So the first forward rate is going to be actually from 6 months to 12 months. And we will use the zero rates, as you can see in our table. If I want to invest my money in the future from the 0.5 to 1 year, then basically I'm going to use these 2 zero rates that are given here. For the first one, I can just exactly take as the initial forward rate as 0.404, which is going to be just at time 0. And the rest of these the forward rates starting from the future of 0.5 years time will be written in this part, and we will have 3 of them, as you can see. So we know how to calculate the forward rate. Basically, we have this investment. This is the interest rate for the 1-year period, and this is the interest rate for the half-year period. So basically, if we subtract this difference and divide by basically the difference in maturities, which is half year in this case, we obtain the forward rate. And you apply the same formula for the rest of the future time to maturities, and you can fill this table. The next thing you can do is basically go to the par yield calculation. And remember, in order to do the par yield calculation, first we need to calculate what is the discount factors for each of these zero rates. And for each of these zero rates, you can calculate these discount factors. You can see this is the zero rate for the half year, and this is for 1 year time, 1.5 and 2 years time. So these are the discount factors for these given time to maturities. And notice that the value of the annuity, if we consider the whole 2 years, is going to be 3.61. So this means basically if I assume I receive $1 at every 6 months, what's going to be the present value? This is called as our annuity term. So basically, if you want to calculate the par yield, what you need to do is again following our previous formula. So we have 1 minus the discount factor for the given time to maturity that you want to calculate the par yield for. So in this case, this is the 0.5, so the discount rate is 0.98. And the sum of the discount rates until this 0.5 is itself, obviously. So what you get for the first par yield of 6 months maturity is 0.408. You can repeat the following formula in a similar way. So for the second maturity, which is the par yield for 1 year, is going to be 1 minus the discount rate for the 1 year zero rate, which is 0.95. And you divide now by the sum of the 0.5 and 1 year discount rates. So basically you have, in this case, 0.98 plus 0.95, which is the discount rate for the 1 year, and you obtain the 1.93. So this gives you the second par yield for the 1 year maturity, and you just follow the same procedure and you can obtain all these basically results that we already presented in this table here. So you can see that the par yields are written here. And you can also notice that the par yields and basically our zero rates are closely following each other. The last thing that we can do in this exercise is basically to calculate the price and yield of a 2-year bond, which provides a semi-annual coupon of 7% per annum. So in the first part of this MATLAB code, what I do is just using the zero rates that we already obtained in order to find the price of the bond. So the price of this bond is $93.80. Okay. And the second thing we can do is now to calculate what's the yield of this bond. In order to calculate the yield, here basically I just do a trial and error approach here, and I'm presenting you the best approximation I got by trying an error. Here you can see that I'm again discounting my present value, but I'm all using the yield. So all the cash flow is discounted with respect to the yield. And again, as you can change this slightly, you will see, for example, if I increase this yield slightly upward, then the price of the bond will go down. So you can try to match this price with this price in order to obtain the yield of this bond. And as I said, by trial and error, I can get as close as possible. You can see the first 3 digits are all the same. So we can say that the yield of this bond is 0.105956.